Meet Oscar, a robot built to go where humans shouldn't. Through collapsed structures, toxic air, and unstable terrain, Oscar moves first, giving rescuers the ice they need before they step into danger. During disasters like landslides, fires, and structural collapses, rescuers face severe uncertainty. Visibility may be poor, air may be toxic, and the stability of the terrain may be unknown. Sending human teams blindly into these environments can waste time and put lives at risk. Oscar was developed to solve this problem. The primary purpose of Oscar is to act as the first observer. It collects temperature, air quality levels, GPS coordinates, and live video from the disaster site, allowing rescue teams to evaluate the situation safely from a distance. At the heart of the robot is a Raspberry Pi 4 powered by a 12-volt LiPo battery. A buck converter provides stable voltage for all components. Movement is handled by four 120 RPM geared motors with rugged rubber wheels built for rough terrain. The sensing suite includes an MQ2 gas sensor for smoke and flammable gases, a DHT11 for temperature and humidity, and a U-Blox Neo 6M GPS module for real-time location mapping. A Logitech Brio 4K webcam provides the video feed, while a servo allows vertical camera tilt.
Our disaster rescue robot is built on a hybrid architecture that brings together real-time control, continuous sensor monitoring, and smooth live video streaming. The Raspberry Pi acts as a co-controller, handling movement, sensor readings, GPS data, and the camera system. It communicates with a Node.js and an Express backend using Socket.io, which enables instant two-way messaging between the robot and the dashboard interface. The system is organized into three main modules. First, the communication module uses WebSocket-based messaging to deliver movement camera commands from the dashboard to the robot, while sending back temperature, humidity, gas levels, and GPS coordinates in real time. The second module is the video streaming pipeline. Camera frames captured on the Raspberry Pi are passed into FFmpeg, encoded in low latency H.264, and streamed to Nginx server using RTMP. Nginx then converts the stream into HSL format, which can be played smoothly inside the browser using hls.js, which provides a stable viewing experience with only about 1 to 3 seconds of latency. This video pipeline can also perform optional human detection. A lightweight neural network model, YOLO V3 Tiny, can analyze each frame and send a simple yes or no detection result to a dedicated Socket.io channel. However, running YOLO continuously on the Raspberry Pi introduces noticeable delay in the video stream. Since responsiveness is critical during real-time robot operations, we use raw streaming by default and enable human detection only when needed. The third module is a browser-based dashboard. It brings together all live information in one place. The HLS video feed, environmental readings, air safety status, human detection indicators, and real-time GPS map using Leaflet. It also provides the movement and camera tilt controls, which are instantly transmitted back to the robot through the server. Altogether, these modules work in parallel to create a synchronized system that offers low latency control, reliable sensor feedback, accurate mapping, and optional person detection. This architecture makes the robot a practical tool for accessing disaster environments before sending human rescuers into danger.
During testing, Oscar successfully navigated over rough surfaces and gentle slopes.
The tilting camera allowed scanning ahead and above obstacles. Sensor data and GPS readings updated smoothly, proving the system's ability to support real disaster site analysis. Future versions of Oscar will focus on stair climbing systems, fire-resistant materials, and a larger chassis capable of carrying additional rescue tools such as extinguishers or first aid kits. We also plan to optimize YOLO to reduce latency and enable real-time human detection. Oscar shows how robotics, real-time streaming, and intelligent sensing can come together to make disaster response operations safer and more efficient. By entering hazardous zones first and gathering critical information, it helps protect rescuers and speeds up decision making. Thank you for watching.